Hello and welcome everyone. Stanford Scholar presents to you the paper HypTrails, a Bayesian approach for comparing hypotheses about human trails on the web.
In any kind of activity on the web, we tend to leave our footprints behind. These chains of footprints are not irrelevant. Researchers find it interesting to understand the processes responsible for these trails. Navigation on the web leaves traces of activity called human trails. How do we understand, express, and compare different hypotheses about these trails is the primary problem this paper intends to solve. So, how did the authors solve this problem? The authors modeled trails and hypotheses as follows. They called a sequence of at least two successive states as trails and assumptions about transition between these states as hypotheses. Now, they used Markov chains to model human trails and Bayesian inference to compare two hypotheses with each other. Next, we'll look at the overview of HypTrails methodology.
The first is the goal, to express and compare hypotheses about human trails. The next part is the method, Bayesian inference and Markov chain model. The idea here is to incorporate hypotheses as priors. Finally, the outcome, partial ordering of hypotheses. Now let's look at the HypTrails methods and ideas in detail. Bayesian inference utilizes the famous Bayes theorem, which is shown on the left. For model inference, we replace A with the unknown parameter theta and B with the dataset D. Now I is introduced to provide an additional assumption to the inference. The Markov chain is used to express human trails on the web. It is represented by a matrix P, whose elements are the probability of transitioning from one state to another. Prior represents hypothesis. The prior belief of the parameters in P is represented by alpha. So the posterior distribution is a combination of prior belief and the actual data. Authors performed experiments using synthetic and empirical datasets. Now, let's look at the results. For synthetic dataset construction based on three different criteria, authors work on 1,000 samples, each of 5 successive clicks. HypTrails ranks these hypotheses that best captures the hidden mechanisms as the most likely one. We cross-link the different datasets with different assumptions and apply the model to find the best result. So the best pairings are structural with structural hypothesis, because this hypothesis has the information about the structure of the network. Popularity with popularity hypothesis, because this hypothesis captures how the trails have been generated. And finally, random teleportation with the uniform hypothesis, because this hypothesis has the belief that target nodes are likely to come from the current node. For empirical datasets, authors compare universal hypotheses with other domain-specific hypotheses related to each dataset, like Wikigame with structural, Yelp with geographic, and Last.fm with date hypothesis. Across all datasets, authors identify some domain-specific hypotheses that are more plausible compared to the universals, since they capture some mechanisms that human behavior exhibits in the observed trails. Let's go over the issues. First, authors use matrices to translate ideas to numbers. So, how do we assign numeric values to represent hypotheses? Next, a symmetric matrix has the assumption that the transition from states A to B has the same probability from B to A. But is this true? Finally, Markov model without memory is a convenient assumption. However, the authors acknowledge that the opposite is also very interesting.
Let's move on to the last section of this talk, real-world applications of HypTrails. Real-world applications can range from predicting user clicks on the web to providing choices on music streaming or restaurant reviewing websites. This can inspire us to improve not just the web but also real life. For example, analyzing pictures in urban settings to better understand human mobility patterns and improve urban city designs. So with that, we come to the end of this presentation. If you would like to view more of our talks, please visit scholar.stanford.edu. Thank you.